Today we are going to discuss about the neuromuscular junctions and we'll do class in English only. Neuromuscular disorders connected with the nerve and muscles, right? The name itself is telling neuromuscular disorders. So we can see this is the nerve, and there are many disorders like we can see amyotrophic lateral sclerosis. We are aware with the name of multiple sclerosis, muscular dystrophy, myasthenia gravis, myopathy, peripheral neuropathy, right? Spinal muscular atrophy, Parkinson, dementia. Few diseases are very common like the dementia, like the Parkinson, like muscular dystrophy, muscular atrophy, like myasthenia gravis, multiple sclerosis. But there are a list of the disease which is coming under the neuromuscular disorders. Because person is not able to walk properly, not able to move properly. So we have to understand the proper, what is the proper reason, what is the right reason, why these people are facing the problem. Then only we can plan the treatment, right? So neuromuscular junctions, what is the meaning of neuromuscular disorders? So for that, we should understand first, what is the neuromuscular junctions? So neuromuscular junction, in the short, we are writing it NMJ or neuromuscular junctions. So this is the nerve, and this is the nerve endings, and this is the muscle, skeletal muscle. So this is the motor nerve, and who is stimulating your muscles? Suppose I want to move my hands. How can I move my hands? I can move my hands only if my nerve are passing the message and muscles are moving. Without the nerve, have you seen the patient suffering with muscular dystrophy? They are walking very slow. And even many other patients like multiple sclerosis, you have seen the patient suffering with the paralysis. They want to walk, brain is giving order, but muscle are not getting that order. So that is coming under the neuromuscular junctions when nerve want to do some order, but muscles are not following. So in this way, when this motor nerve giving some order, but this muscle, or we can tell the skeletal muscle, not following this order, then there is a problem happening. So the junction of this nerve and this muscle, this junction is called neuromuscular junction. And there are lots of events happening in these junctions responsible for the various type of movement. So we will be discussing these multiple events to understand this. So first I would like to tell you what is nervous system. Nervous system is the super commander controller. We can divide in two parts, CNS and PNS. CNS means central nervous system. And the central nervous system means brain, which is a supreme commander, and spine. Together are called central nervous system. Now the nerve coming out from the brain and the nerve coming out from the spine, these nerves are called peripheral nervous system, means the cranial nerve. coming out from the brain and the spinal nerve coming out from the spine. These are called peripheral nervous system. So the central nervous system living in the center and the peripheral nervous systems are supplying entire body, right? So if we see in this image, we can see here, this is the brain. So brain is the part of central nervous system. This is the part of entire brain. Brain is the part of central nervous system. And the spine, this is also the part of central nervous system. Then we can see the lots of nerves are coming out. We can see the multiple, these golden color nerve. In this diagram, we can see with the golden color, these all nerves who are coming out from the brain, who are coming out from the spine. These nerves are called peripheral nerves, peripheral nervous systems, right? So in this way, we have seen the nervous system is having two parts. Okay. Now, so if we talk about the spinal nerve, let's talk about the spinal nerve. The spine is giving origin to two types of nerve. Number one, suppose someone is pinching us, we are feeling pain. So this message coming to the brain, then we are telling, oh, don't pinch us, please don't pinch us. Or we are walking, suddenly we are getting some pain. So that is pain and sensation, that is a part of sensory nerve. They are received by the spine. And also, if you want to perform some action, or we are telling if you want to do some activity, like I want to lift my hands, I want to walk, I want to play the volleyball, basketball, football, I want to run, I want to do some actions. So this is called motor action. So the message is coming through the motor nerve, reaching to my muscles. Then I can move my muscle. So the main task here we have to discuss about the motor nerve, right? So if we talk about the motor nerve, so suppose this is the spine. In the spine, there is a anterior horn, means some part of the spine, anterior horn, from where this spinal nerve are coming out, or we can tell the motor nerve are coming out. Then reaching to the skeletal muscle, right? So look at here now. So we can see this is the nerve. So from the spinal cord, this nerve, this part is taking exit. So this is called the head of nerve. And this is called, the last part, this is called the tail of nerve. So the head of the nerve is called, cell body. We can see in the cell body, we have the nucleus. So cell body is having nucleus, cell body is having DNA, and cell body is prime controller. Then we can see this nerve is going away from here. And the last part is, this is called the nerve terminal or nerve ending. So we are telling it nerve ending, the last part of the nerve. Or we are telling it nerve terminal, last part of the nerve. So the message is from the cell body is coming to the nerve ending. Suppose I want to do some movement, and the command is coming from the brain, then in the spine, Then from the cell body, this command is passing in the form of electric current, electric signal. So these electric signals are reaching to the nerve ending. We are telling this electric signal action potential. What is the meaning of action potential? The meaning of action potential, when the electric currents are passing through the cell body to the nerve ending, this electric current is called action potential. Because this electric current will do the movement afterward. And remember one word, when muscle is doing contraction, so we are telling is depolarization. Depolarization. Try to understand this word, depolarization. Polarization, right? Why we are telling depolarization? Depolarization means when muscle is doing contraction. These words always you can see when you talk about the muscle movement. Depolarization, repolarization. So what is the difference between de and repolarization? So in the muscles, one person who is always responsible for contraction. What is the name of this person? The name of this person is sodium. Sodium will go wherever the sodium will go, will do contraction. So we can see when sodium will go, sodium is going with this plus sign. Like we know we are like in the salt we are having sodium chloride, and there are many vegetables we are having sodium. Sodium is found in many things. So wherever sodium goes, sodium is going with this plus sign. So suppose this is the sodium is here, and suppose sodium is going this side, and as soon as sodium will go this side, here it will convert in the form of plus because sodium is plus. So this is called changing in the polarity, changing in polarity. We can understand one example. Suppose this is the muscle home, and this is the other home, right? Or forget the muscle home for a while. You can consider this is the area 1 and this is the area 2. In the area 2, there is a lots of females. And we know females, so there will be minus polarity. And on the area 1, there are lots of male, so having plus polarity, right? So as soon as the male will go to the other side, there are too many males are going other side, so they will bring other different types of the polarity. So this is called changing in the polarity. So wherever sodium enters, if sodium is entering here, it will do contraction. So that's why we are telling changing of polarity or muscle contraction or depolarization. So we will use this word depolarization. it means muscle contraction. After muscle is contracted, now it want to become again like earlier. It want to relax again like earlier. It want to regain the same polarity again like earlier. It want to send back the sodium in the area 1. So when the muscle is relaxing, getting the polarity like earlier, we are telling it a repolarization. So try to understand this word. Depolarization we are using for contraction, or we are telling if the depolarization will happen, then muscle will start contracting, because polarity will change, then muscle will start contracting. And as soon as polarity will become like earlier, muscle will relax. So this is relaxing the muscle. Right. So but just we have to understand one thing. So whenever sodium is entering anywhere, it will bring the contraction. It will change the polarity. We are going to use this condition multiple times. So here we have discussed that this is the nerve. And we can see this is the cell body. This is the nucleus. A nucleus with the DNA. And this is the head of the nerve. And here we can see the tail of the nerve, or we can tell nerve terminal. Nerve terminal. And the electric current who is passing through the nerve, it is called action potential. Who will bring action? So electric current is coming like this. So suppose electric current passing. So let's see, this is the spine. In the spine, this is the anterior horn. From there, this nerve is coming out, and let's make the nerve terminal little bigger so we can understand very properly. This is the so we are telling, okay, from the spine, from the anterior horn of the spine, spinal cord, the action potential coming in the form of electric signal, right? Then it's reaching in the last part of the nerve. But our target is doing the contraction of this skeletal muscle. We want to move the muscle. So as the nerve is ending, now this electric message will convert in the form of chemical message. Chemical message. Now this message will forward in the form of chemical message and will stimulate this muscle. What is the meaning of chemical message? The meaning of chemical message, suppose we have perfume and we are spraying the perfume. Then lots of particles will be spreading around, and then we can feel the smell. That is chemical signals, right? In the same way, because nerve is ended here, now there is no direct connectivity with the muscles. There is a gap. So in this gap, the message can transfer only in the form of chemical signal, right? So we can define in this way once again. So nerve is sending the electric current, electric signal. Then from the nerve, this is going ahead in the form of chemical signal, then it's acting on the muscle. This is the skeletal muscle. And as soon as it's reaching to the skeletal muscle, again it's becoming the electric signal. And muscle doing contraction. And muscle movement is happening. So we can see here how the message is passing first through the electric signal, then the chemical signals, then again in the muscle, it's changing in the electric signal, and there is a contraction of the muscles is happening. These all events are happening in the neuromuscular junctions. We have to have the very good idea about this, because then only we'll able to understand neuromuscular disease like the myasthenia gravis and many other diseases, right? I will tell you, there are some tribes, what they're doing. They are hunting with some poisonous arrow. So they are having some poisonous arrow. And they are hunting maybe they are hunting the humans, they are hunting the animals. So as soon as this poisonous arrow is coming in the contact of human or any animals who is having neuromuscular junctions. All the animals and human are having neuromuscular junctions. So immediately they get paralysis. They can't run, even they can't fight due to this poisonous arrow. So what the poisonous arrow do? Because suppose you want to run, right? Then your brain is giving message to your muscles, okay, run. And this action will happen at the neuromuscular junctions. So immediately your nerve are giving order to your muscles, okay, run fast or the fight back. We are under the threat, we are under the danger. But as soon as this poisonous chemicals are going in your body, in the human body or in the animal body, they are blocking this path. They are blocking the path of skeletal muscle. Now the electric current is coming. And it's also sending the information of in the chemical signal. But it cannot work on the muscles because it is blocked by the poison. So they get paralysis of muscle. Right? There are very famous medicine, the famous poison, curare. Many tribes using this for hunting the humans, animals, even they putting it in the water pond. So all the fish paralyzed and will coming on the surface of the water, then they are catching them. Right? So there are many other diseases like due to botulinum toxin, and there are many other problems we'll discuss. So first we have to try to understand. This junction is very much important if you want to perform any action. Now we have to understand the anatomy properly of this junction. So suppose this is the nerve coming from the anterior horn, and this is a nerve terminal. Then we can see this is the skeletal muscles. Right? This gap in between the nerve and the muscle, this is called synapse, right? Or we are telling it synaptic cleft. All the lots of events happening here. So this is called synapse. So nerve, this membrane, this is the before the synapse. It is called presynaptic membrane. Presynaptic membrane. And this is the muscle fiber, and the membrane of the muscle fiber is called postsynaptic membrane. Right. So the message is coming from the presynaptic membrane to the postsynaptic membrane. So when this action potential is coming in the nerve first, then it's taking the form of chemical signals here. Then it's acting on the muscle layer. Then the movement is possible. So this entire process is called neuromuscular transmission. Means the transmission of the message happening between the nerve and the muscle, right? Fine. So now, so let's see if this is the nerve terminal, the nerve ending, the how the nerve terminal sending the chemical signal. And what is that chemical signal? This is very important thing, chemical signal. If we have the proper idea of this chemical signal, then we can think about the myasthenia gravis. So in the nerve ending, there are pouches. There are many pouches, too many pouch. The name of these pouch are vesicles. Vesicle means pouch. And in this pouch, there are lots of chemicals, dots, lots of chemicals are stored. Like we can see, you are having perfume bottle, and inside you are having perfume, right? And perfume is chemical. So inside the pouch, these chemicals are stored. These chemicals are very much important. These chemicals are called neurotransmitter. And if we talk about what is the meaning of neurotransmitter, the meaning of neurotransmitter, who are passing the message in the form of chemical. And the name of this neurotransmitter who found in the nerve ending, that is acetylcholine. It's a very important neurotransmitter. If it will decrease, then will not able to perform the muscle movement. So in the vesicle pouch, in the vesicle, there are acetylcholine. So when the action potential or the electric current is coming, then vesicle are coming in the contact of this nerve ending membrane and releasing the pouches here. releasing the acetylcholine. So there are many pouches are coming in the contact of this membrane, presynaptic membrane, and releasing this chemical acetylcholine. And more the acetylcholine, more the muscle contraction. Or we are telling more the acetylcholine, more the muscle depolarization. So this acetylcholine play a very important role. In the many disease, this acetylcholine is decreasing. So this acetylcholine is working in the synapse, right? So we have seen now. So chemical signal means acetylcholine. So generally, when there is a formation of the acetylcholine is happening here only, and they are depositing inside the nerve. Now, the acetylcholine means acetyl plus choline. Acetylcholine means, if we talk about the acetyl, actually this each and everything is important. So I don't want to skip. Maybe I can jump and I don't describe that how the formation of acetylcholine. But then we will miss the understanding of one disease. So let's see the formation of acetylcholine. Acetylcholine is the combination of two things. Number one, acetyl CoA, and number two, choline, right? So acetyl CoA is coming from mitochondria. Mitochondria found here. Mitochondria is energy engine. This is a theoretical part, but we have to have full idea. So mitochondria is producing this acetyl CoA, and choline is coming from outside. Then acetyl CoA and choline. This is the acetyl CoA and this is the choline getting fused together and making acetylcholine. So again, it's very simple. Acetylcholine made by two things. Number one, choline coming from the outside. Choline coming from the outside, there is one special gate, a special receptor, a special channel. From there is entry of the choline. And mitochondria is producing acetyl-CoA. Then, like we can understand in this way, like we want to make the tea, right? So what we are taking water and we are taking milk. Then we are using fire to boil it. Then we will be able to make the tea and we are putting some more ingredients. In the same way, the acetyl-CoA coming from the mitochondria and choline coming from the outside through the special receptor or the channel. And there is a fire. Fire means some enzymes. They are mixing them and making the acetylcholine. And acetylcholine is the final neurotransmitter. So this name of enzyme also I would like to tell you here. The name of this enzyme. Who is doing this work? that is called choline, acetyl. So this is the name only, transferase. Name is very simple. So now, in the presence of this enzyme, there is a formation of acetylcholine. So we can see in the nerve endings, there are many pouches, but they are empty pouches or the vesicles. And because of this enzyme, there is a formation of the acetylcholine and it's coming inside and increasing the concentration of acetylcholine inside the vesicle, right? So now when there is a need, they will get washed out and will release the neurotransmitter. In this way, the action will happen. In this way, there is a further reaction will happen. Is it understood by everyone? Clear? Okay. So now, we have to understand few more things which is happening inside the nerve endings. So here you can see this is the nerve and this is the skeletal muscle. And we can see how the message is passing from nerve to the skeletal muscles on the neuromuscular junctions. Now the most important thing here, we have to understand most important thing. Now please keep open your mind. Very easy things, but we have to understand. So this is the nerve ending. This is the nerve ending. Or the nerve terminal. And here we have a skeletal muscle. Now the step number 1, the electric current will come from here. This is the electric current or action potential. Electric signal or action potential is coming. As soon as it's reaching on the nerve endings, nerve terminal, this is the part we can see, this is the nerve ending or the nerve terminal. So because of electricity is reaching here, there is some changes in the nerve ending because current is coming here. Then there is some changes will be here. So as soon as the electric current reaching here, what will happen? There will one event will happen that is called sodium pump will open. Sodium pump will open. Now what will start? I already told you, whenever you want to contract anything, sodium start going in. As soon as the electric current going here, sodium start going in. And it will bring the plus polarity in because it was minus polarity earlier. Now it will bring plus polarity in. If you see, then it's already given that there is inside polarity will be, normally the polarity of inside is minus 70 millivolt. But sodium will come and will change the polarity and keep on changing the polarity. Even it will take the polarity till the plus 10 millivolt. So now what is this? Changing in the polarity, or we are telling it depolarization. Depolarization means changing the polarity, and the meaning of depolarization means contraction. Right? So this thing will happen at the nerve ending because of the sodium going in. When the sodium going in, this is called sodium influx. So sodium going in. Now we have to remember one thing. When the sodium go in here, there is one friend of sodium. As soon as the sodium start going in, there is a friend of sodium who also start going in. And this is a very important friend. The name of this friend is calcium. So we can see sodium is the leader, like someone entering somewhere in the first queue, first line. And in the queue, there is a calcium, right? Calcium here. So this is the sodium and this is the calcium. So as the calcium go in, and calcium is very important because now the next process will happen due to calcium. We know that we are telling, okay, I'm suffering with the calcium deficiency. If you are having calcium deficiency, you will not able to do the muscle movement. You will be having muscle cramps, and you are suffering with some problem of the muscle movement. That's why many athletes, many runner, they're using too much these calciums. So they suffer with the calcium deficiency. So they have to refill themselves again with the calcium. Because more you are using your muscles or the neuromuscular junctions, you are in the need of more calcium. Because without calcium, you can't do contraction. So sodium influx is happening here. And because of that, calcium also start going in. This is the event happening here. So here we have to understand one thing. Sodium is going through one special door. This is called voltage gated sodium channel. So in this way, how we are explaining, we can explain in this way. So number one, from the anterior horn of the spinal cord, the action potential is coming. Then is reaching to the nerve ending. And as soon as it's reaching to the nerve ending, immediately there is sodium influx start through the voltage gated sodium channel. And because of that, calcium also start going in, right? And then we can see the depolarization is happening in this part. Depolarization. Again, I will tell you what is the meaning of depolarization means. Polarity changing, because sodium going in, even the calcium going in. So there will be changing in the polarity. Depolarization will happen here. So we have to remember this thing. And we have to remember the importance of calcium here. Suppose if we block the calcium, muscle cannot contract. The calcium entry is mandatory to do the muscle contraction, right? We have to remember the each and everything, because when doctor are giving medicines, so what doctor are giving? They are giving some blockers. What is the meaning of blocker? They will restrict some entry. They might restrict any entry. So the contraction will not happen, right? Now till here, story is very simple, right? Calcium is moving in. Now the story, the next story. Next story. So as soon as calcium go in through the special channels, right? And there are vesicles. We already know there are vesicles inside. Vesicles who are having neurotransmitter acetylcholine. We already have discussed earlier. As soon as the vesicles are looking the calcium, wow, they smile. So vesicle are smiling. And they are welcoming the calcium. Please come and attach with me. Right. Then calcium is attaching with these vesicles. Then calcium are telling the vesicles, okay, now release the neurotransmitter. Right. So vesicle needs support of calcium, or we can tell calcium we can understand like some car or some vehicle who will support, then only vesicle will open and release the neurotransmitter. Now this vesicle will come in the contact of this membrane and will open here and will able to release this acetylcholine. Then only acetylcholine will go and will be working on the skeletal muscle. So story, what is the story? Story is this. The action potential coming from the anterior horn of the spinal nerve, then voltage gated sodium channels are improving the sodium influx, which is promoting entry of calcium through the special channel or receptors. And they are doing depolarization, changing in the polarity or the contraction, or depolarization, changing in the polarity. Now calcium is going in, vesicle are smiling and welcoming the calcium. And as soon as calcium attaching on the vesicle, then vesicles are releasing the neurotransmitter acetylcholine, and it's working on the skeletal muscles, right? Then we are able to do the movement. So this was the incident. This was the event. Now, so we can tell what is vesicle. What is the quality of vesicle? We have to understand here the quality of vesicles. Vesicles means pouches. In the pouch, we are having acetylcholine neurotransmitter. So we can tell vesicles are calcium sensitive, right? Calcium sensitive. And they are attaching the calcium on the surface. So they are calcium sensitive. Now I would like to tell you the release of acetylcholine, how the release of acetylcholine is happening. These all events are important if you really want to understand the neuromuscular disease. So means we want to discuss this, that from this pouch, how the acetylcholine is releasing. This releasing the acetylcholine, this process is called, we are having the particular name of this process. The name of this process is exocytosis. Exo means out, endocytosis means coming in. So the meaning of exocytosis means releasing of acetylcholine from vesicle to synapse. So we are going to understand the process of exocytosis, right? Is this enough, or shall we continue a little more? Are you able to understand? Nerve endings are very thin, very thin, but enough. Okay. Very thin. Okay, fine. Okay, so please see the video today once again. So I will announce in the group master acupuncturist group for the next class, maybe tomorrow, or right. So you have to go through with the video first, so that we will understand what is exocytosis. Then we'll understand few more things. Then we'll start the discussion of myasthenia gravis and some other disease, right? Okay, thank you so much. Let's close the session. See you again. Thank you.